Hello everyone, I am Dr. Sirajul Akfaisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about carboxylic acid. So what is carboxylic acid? You can see the carboxylic acid formula, RC double bond OH. So C double bond OH actually the functional group of carboxylic acid and R is here alkyl group. So this may be aliphatic or aromatic residue. Now example, aliphatic oxalic acid, citric acid, succinic acid, and tartaric acid. Aromatic, salicylic acid, benzoic acid, and phthalic acid. Now, aliphatic carboxylic acid. You know, aliphatic carboxylic acid, for example, oxalic acid. So, compound oxalic acid, class aliphatic carboxylic acid, in a structure you can see here. This is the structure of oxalic acid. Now, oxalic acid, state solid, color white, odor odorless, action on litmus paper, acidic turn blue litmus paper to red, and dry ignitions, powder cherry. Now, oxalic acid, you can see solubility in water soluble, HCl soluble, 30% sodium hydroxide soluble, sodium carbonate solution soluble. So few powder with a lot of liquids. Must grind powder to fine before use. Now oxalic acid. General test sodium carbonate test give effervescence and perichloride after neutralizations test give yellow color. Conformity test calcium chloride test give white precipitate reductions of KMnO4 in acidic medium. My friend, sodium carbonate test. How you will perform? Take 0.5 gram of oxalic acid and dissolve it in water. Add sodium carbonate powder to sample solution, gives effervescence. So this is the test. Now, ferric chloride after neutralization test. Take 0.5 gram of oxalic acid, then add dilute ammonia 1 ml by 1 ml with vigorous shake till appears ammonia odor. Now heat on direct flame till disappear the ammonia odor. Cool, add 3 to 5 drop of ferric chloride gives yellow color. You can see here. Now ferric chloride reagent has dark yellow color. So must make blank to differentiate between the yellow of oxalic acid and yellow of reagents. So blank powder plus 3 to 5 drop of N ferric chloride without sample. So you can see the positive, you see the negative. Now calcium chloride test. 3 ml sample solutions plus 2 ml calcium chloride, immediate white precipitate. And this is the test. Now reductions of KMnO4 in acidic medium. Take 3 ml solution plus 1 ml dilute sulfuric acid plus 5 to 4 to 5 drops KMnO4, warm on flame. Then you will see the dechlorizations. Now aliphatic carboxylic acid like succinic acid, compound succinic acid, class aliphatic carboxylic acid, and a structure formula you can see here. Succinic acid state solid, color white, odor odorless, action on litmus paper acidic, turn blue litmus paper to red, and dry ignition powdered cherry. Now succinic acid you can see the solubility in water soluble, hydrochloric acid soluble, 30% sodium hydroxide soluble, sodium carbonate solution soluble. Few powders with a lot of liquids, so must grind powder to fine before use. Now succinic acid general test, sodium carbonate test give effervescence and ferric chloride after neutral test give buff precipitate and conformity test fluorescein test. Now you can see ferric chloride after neutralization test, take 0.5 gram of succinic acid, then add dilute ammonia 1 ml by 1 ml with vigorous shake till appear ammonia odors. Then heat on direct flame till disappear the ammonia odor and cool. Add 3 to 5 drops of neutral ferric chloride gives buff precipitate. Now fluorescein test. Mix a small amount of succinic acid with equal amount of resorcinol. You know the resorcinol. Add 2 drops concentrated sulfuric acid. Fuse on direct flame. Cool. Add excess 30% sodium hydroxide. The results green fluorescence appear will after dilution with water. You can see here. Now, aliphatic carboxylic acid, tartaric acid. The compound tartaric acid, class aliphatic carboxylic acid, structure you can see here. Now, tartaric acid states solid, color white, odorless, action on litmus paper. Acid turns blue litmus paper to red and tri-ignition powder sharing. Now, tartaric acid solubility in water soluble, in chloroform, hydrochloric acid soluble, 30% sodium soluble, and sodium bicarbonate solution soluble. So few powder with a lot of liquids and must grind powder to be fine before using. Now tartaric acid general test. Sodium carbonate test give effervescence. Neutral ferric chloride after neutralization test give yellow color. Conformity test. Calcium chloride test give white precipitate. Dengue's test. Now calcium chloride test. Take 33 ml sample solutions and 2 ml calcium chloride. White precipitate after scratching. Now Dengue's test. 3 ml concentrated solution. 2 ml D1 boils till clear solution and 1 to drop D2 KMNO4 and complete boiling. You can see the decolorizations. Now aliphatic carboxylic acid, citric acid, class aliphatic carboxylic acid, and structure you can see the citric acid. State solid, color white, odorless, action on it turn litmus paper to red and try powder shading. Now citric acid solubility in water soluble, chloroform, hydrochloric acid soluble, 30% sodium hydroxide soluble, sodium carbonate soluble. So few powder with a lot of liquids must grind powder to be fine before using. Tartaric acid. General test sodium carbonate give effervescence. Ferric chloride after neutralization give yellow color. Conformity test. Calcium chloride test give white precipitate. Dengue's test sodium nitroprusside. Now calcium chloride test. 3 ml sample solution, 2 ml calcium chloride, white precipitate after boiling. You can see 3 ml concentrated solutions, 2 ml D1 boil till clear solution, add 1 to drops D2 KMNO4 and complete boiling, decolorizations and white precipitate. Now sodium nitroprusside test. To solution of concentrated sulfuric acid and 2 ml water plus 2 ml sodium nitroprusside, excess sodium hydroxide and blood red color. You can see this is a nitroprusside. So identification of solid or called carboxylic acid. Dry ignitions, inflammation with non-smoky flame and no residue. It may be aliphatic acid. Sodium carbonate, positive effervescence. It is aliphatic acid, oxalic, tartaric acid, citric acid or succinic acid. Concentrated sulfuric acid test. Distilled half spatula plus 1 ml concentrated sulfuric acid and heat for 15 to 30 seconds maximum on flame. Now neutral ferric chloride test. 5 ml solution of and sodium ammonium hydroxide till ammonium odors. Then heat till no ammoniations odor to remove excess ammonia. Cool and add 2 drops ferric chlorides. So effervescence, no blackening, yellow color, it may be oxalic acid. Effervescence, blackening, yellow color, it may be tartaric acid. Effervescence, yellow solution, yellow color, it may be citric acid. No effervescence, no blackening, buff precipitate, it may be succinic acid. Now neutral ferric chloride. Why it cannot be done on acid? Organic acid are weak acid, weak electrolyte, so they are partially ionized. You can see the acetate ion ionized. The anion acidic radicals is responsible for reacting with the ferric chloride and performing the color by complexation with iron. So for increasing the concentration of ionized ions, we make neutral solutions because according to Lechetli principle, ammonium hydroxide base will react with the H+, decreases its concentration, shifting the equilibrium to the right side. You can see here as it reacts with the OH of ammonia. Now this is the reactions. Ferric chloride react with this. So how can we prepare neutral solution of acid? In test tube, add 1 ml unknown plus excess of dilute ammonium hydroxide detected by others, and solution now as it contains excess ammonia. Boil the solution till no ammonia odor is evolved to get rid of excess ammonia, and cool, add 2 drops of ferric chlorides. So why solution cannot be basic? If excess ammonia not removed in second step, ferric chloride ammonium hydroxide, you will see brown precipitate, and the brown precipitate of ferric oxide interfere with the color of the product, leading to the false result. So boiling to remove excess ammonia is critical. So pharmaceutical application of aliphatic carboxylic acid. You know, oxalic acid, it is a poisonous in its pure form, only consumes it from natural sources, tomato, spinach, and is a normal element in human blood and must be available for immune system to fight the disease of cancer, viral, and bacterial infection. You know, oxalic acid and oxalates are useful as a reducing agent for bleaching and dust removal, and they are widely used as a purifying agent in pharmaceutical industries. Also used as in vitro anticoagulants in blood bags to complex with the calcium and prevent activation of blood clotting factors. You know, my friend, if level of oxalic acid increase in blood, it precipitate as a calcium oxalate crystal in kidney or ureter, causing renal stones and renal colic. So what is the importance here? Citric acid. Citric acid is naturally occurring acid found primarily in citrus fruits such as lemons and orange. So used as a flavoring agent to produce citrus flavor. Found in many different processed food and soft drink, as it is a effective organic preservative and powerful cleaning agent used in the household. Bleaches as a water softener to remove hard water. Now added to ice cream as an emulsifying agent to keep fats from separating. Citric acid is used with sodium bicarbonate in wide range of effervescent formula. Anhydrous citric acid is widely used as in vitro anticoagulant in the blood bags to complex calcium and prevent activation of blood clotting factor. Now, tartaric acid. You know, tartaric acid is found in baking powder where it serves as a source of acid that react with sodium bicarbonate, baking soda, and this reaction produces carbon dioxide gas and lets produce rice without any yeasty taste. Now, succinic acid as a food additive and dietary supplement as an excipient pharmaceuticals product is used to control acidity tablets. Succinic acid is used in food and beverages industries. You know, primarily as an acidity regulator. Now, assignment MSTS of this carboxylic acid and pharmaceutical applications. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.